Hey, Year 10s, how's it going? I totally realised, thanks to Lara, kind of realised that the lesson started at 2:35. Oops! Oh, good times. Good times. Mr. Duncan, have you watched Dragon's Den? I'm just... Oh dear, let's turn that sound off. Is my sound okay? I've been having issues with my sound recently. It's not gone well. Two chemists go into a bar. The first says, I think I'll have H2O. The second one says, I think I'll have H2O too. And he died. Yeah, indeed. Audra and Atia, you're in the house? I like it. So I'm still missing Caitlin, Mel, and Kayla. That's who I'm now missing. Since Lara's absolutely right and the lesson started all of 4 minutes ago, I'll crack on and I'll mark them as missing and then mark them in when they arrive. That's what I'll do. Okie dokie. I'll call. Good job. Thank you. Thank you. Right. Okay, guys. Let's crack on. Acid. There was a guy who was promoting his product of cow sperm from a cow called Perfect Storm. Yeah, both have music now. Kaylin, hi, so I'm late. Oh, hi, Kaylin, thanks for coming. Hi, Mel. Good job, everyone's here now. Just Kayla, I think, who is running a little bit late. Cool. Okay, guys, I'm gonna get on with the lesson. I'm gonna get on with the lesson. Right, first things first, guys, you know the drill. You know the drill. Yeah, I'm going to share my screen with you guys. And we're going to go through the homework because I set you guys a homework. Let's go share screen. Share screen. Share. And that one. And that one. She couldn't find it. Oh, okay. Right. Okay, guys. We're in. And homework already. Right. I'm going to continue to collect all my data on that sheet that I created earlier. I don't have to copy names across again. So we're doing solubility today, but before that, I set you guys a homework. Nice thing here, I thought this was lovely. Where do we key in our results, Mr. Duncan? In the same sheet that you've been doing it the entire time, Dom. If you want me to reshare it with you, I can if you need me to. So metal plus acid, they just want the general overall word bit. Salt and hydrogen, there's MASH. Gotta love MASH. Then we go metal oxide plus acid, salt and water. It's French for water. metal hydroxide plus acid, salt and water. Metal carbonate. Now that one's the only one that's different now. So we've got water and CO2. Carbon dioxide, everyone. There we go. Ammonia plus acid. Oh, I wonder how many of it. Kayla. Hi, Kayla. Thanks for coming. Guys, sorry. Salt. Ammonia is I think I've spoken to you guys about ammonia. So I'm just going to quickly do a quick run through on that. There's my solubility rules I'll be using in today's lesson. But I'm just going to quickly explain ammonia. Yeah, ammonia is a rather odd substance. Ammonia, number one, is a gas. Yeah, NH3 gas. Yeah, and when it reacts with an acid, let's react it with HCl. There's a rather odd thing, which is instead of the hydrogen splitting off and either becoming hydrogen gas or water, it combines with the ammonia molecule to form ammonium. Yeah, so you get NH4Cl and no other product. 100% atom economy. Oh, you guys don't do atom economy at GCSE. Sorry. So yeah, 100%. Yeah, I'll just stop there. So ammonia is a rather odd one because they combine together. Because if you want to see the proton transfer, by the way, yeah, in reality, here's what's happening. So this is what's called this is the overall equation. This is the overall equation. Just giving you those little bits. And by the way, this is more of an insight into A-level. GCSE still stands, of course. And it's still seen every now and again. But this is more of an A-level trick. So you guys picked up the ionic equation of neutralization. H plus plus OH minus goes to water. Well, this does something similar. Yeah, we've got that. The ammonia is what's acting as the base. It is a proton, remember, a Bronsted-Lowry base is a proton acceptor. And I now know it's acceptor because its name is a donor. Yeah, HCl is the Bronsted-Lowry acid. And they combine together to form ammonium. If you want it as a picture, Mel, Mr. Duncan, I just wanted to ask if in the future you could tell us about the homework a bit more earlier so we have more than a day to complete it. Mel, if you don't have time to do the homework, then don't do it. Yeah, and then do it later on after I've done the webinar. Mel, you know me. Yeah, I am not one of those Look, guys, if you don't want to do the homework, don't do the homework. That's it. It's all like that. I'm not going to go further into this. That's up to you. If you can't find the time to give me 10 minutes on chemistry, then don't do it. It's all right. I won't be upset by it. Yep. So just to show you this as a picture, it's quite nice to show this dot and cross. Ammonia, of course, is covalent. Yeah. All non-metals. So we've got dot and a cross in each of the gaps, and then nitrogen has a lone pair of electrons. Yeah, so there's the picture of ammonia. It's not that we don't want to do it, it's that we have classes after school. It's okay. Mel, you know me. Like, in reality, Mel, I know I set you the homework because the homework goes with that lesson, and I want to be able to go through it in the next one. Like, if you don't have time, don't worry about it. Like, in fact, just speak to any of the boys who don't do it on time anyway and then go through it after. Lol. Just, honestly, Mel, it's not a big deal. Honestly, it's not. I'd never be upset with anyone for not doing a homework. Like, the homework is there to make you a better chemist, but if you don't have time, do it during, you can even, let's be honest, Mel, let's be fair. You could pause the webinar. You could then do the homework, then watch my webinar, mark it. I'll know that you won't be in the lesson if you don't give me feedback, but it doesn't really matter. Yeah, come on, like, this is me. You guys know me. Yeah. So just to show you what's happening, H plus, of course, is rather odd because H plus has no electrons. It's just a H. So it's just a proton, no electrons. What's going to happen is the proton is picked up by the ammonium and forms a bond with it. So it's quite nice to be able to see that in terms of bonding. If you want an image in terms of what's called a mechanism, here's the mechanism of what's going on. This is, again, more of an A-level term, H plus. This is, there you go. So the electrons are going towards the H plus and forming a bond with it. So it's quite nice to see that. But ammonia is very special, and it does make an appearance at GCSE. So do you know what? I kind of hope that you would have done a little bit of research perhaps on that one to discover it. If you didn't, don't worry about it. So 5 marks, folks. 1, 2, 3, 4, 5. Let's move on. Next, salts. Complete the salts. Okay. Oh, complete the table to show the name of the salt formed when the following reactions happen with the base. So you don't need anything else. Yeah, this is just the salt. So this is going to be, and it says the name, yeah, rather than the formulae. I don't really like that. It's an awful lot of words, that. Yeah, so this one's going to form sodium nitrate. Yeah, sodium nitrate, formula NaNO3. This one's going to form sodium chloride, hydrochloric. Yeah, sodium chloride. It's nice for me to then go NaCl. Then we're going to have sodium sulfate. Yeah, so I'll give it the words and then the symbol. Yeah, sodium. It's going to take me an awful lot of time to write all those words out. It's with an F, not a PH. Sodium sulfate, Na2SO4. I'm going to switch to symbols, folks, to speed this up a bit. Yeah, magnesium nitrate, MgNO3 twice. Then magnesium chloride, MgCl2. and then magnesium sulfate MgSO4, because Mg is a 2 plus, SO4 is a 2 minus. All the other two were 1 minuses, so you've got to have the multiple number of the anion. Right, potassium nitrate KNO3 plus 1 minus 1, so 1 to 1. Then we get, potassium chloride plus 1 minus 1, but then the sulfate's a 2 minus, so K2SO4. After a while, you do get used to this. Right, this one's a clever one because they didn't tell you it was a 2. Their Roman numerals should have been there, but it is in fact a 2 because the hydroxide is a 2. So I'm going to form copper 2 nitrate. And if you give the name, you need the number. Then you need copper 2 chloride, and then copper 2 sulfate. There we go. Don't forget your Roman numerals whenever you're doing a transition metal compound. Next, ammonia. This is going to be ammonium nitrate, NH4NO3. This one's going to be ammonium chloride. Yeah. And then this one's going to be ammonium sulfate, which is a bit more tricky because you've got to have the brackets around the ammonium. There we go. The only one there that worries me is the copper, and it requiring the Roman numeral for all of those guys. Yeah, they all require the 2 on the Roman numeral. Yeah, copper 2 nitrate, copper 2 chloride, copper 2 sulfate on the name. Next, right, complete the following equations. Now, part B is, part C. On the back, write the balanced equation. Okay. 10. Let's see how long it's going to take me to do this. Right. Now, once again, an interesting question number 1. Star that one. Now, it's gone iron plus hydrochloric acid, which means we're going to form iron chloride, but is it going to be iron 2 or iron 3? Iron 3 is actually more stable than iron 2, but I don't mind if I've actually told you a rule, which is if you don't know, give it a 2. Yeah, it's a good rule to have, to be fair. Good rule to have. But in this case, it would probably form iron 3 chloride, but it makes no difference. So I'm going to form iron 2 or 3, whichever one you've decided to do. Iron 3 chloride, and of course, hydrogen gas. And the reason being is because it's a metal, and metal plus acid, salt and hydrogen. Balanced equation, Fe, see if I can make it a bit bigger, Fe plus HCl. I've gone for iron 2 in this case, so I'm going to go for FeCl2 plus H2, balance it with a 2, and I'm done. State symbols, if you wished. The metal, of course, would have been a solid. All acids are aqueous. The salt will therefore be aqueous, and the hydrogen would be a gas, even though you don't really need state symbols. Next, hydrochloric acid plus copper carbonate. Right, we're assuming copper 2. They should have told you that it's copper 2 carbonate. There we go. Copper 2 carbonate. Again, them not being particularly consistent, but copper is most commonly 2 plus. So we've got HCl plus CuCO3, copper 2 carbonate, we're going to form copper 2 chloride plus water plus CO2. Oh, suddenly realized that you kind of want the word one first. Okay, hang on. Word one first. I'm going to form copper 2 chloride plus water plus carbon dioxide. Carbon dioxide equation. Words, of course, you never need to balance. So I've got hydrochloric acid, HCl plus CuCO3 goes to CuCl2 plus CO2 plus H2O. Balance it. 1 H, 2 H's. Right, start again. 2 H's, 2 H's, 2 Cl's, 2 Cl's. 1 copper, 1 copper. Yeah, got to make that really clear so it doesn't look like a Ca. Yeah, there we go. I'll do the same thing for that one as well. CuCl2. I think that all adds up. I believe it does. If they didn't write the Roman numeral in the question, will we get it wrong if we didn't write the Roman numeral? Lara, they will always, in the GCSE, they'll always give, well, they won't give you it for silver because it's always +1. I wouldn't worry too much about that. If they didn't give the Roman numeral and you did, that's fine. If you didn't, I don't think they'd care. So yeah, not too worried. Next, going to do to words to symbol. Iron 2 hydroxide, Fe brackets OH 2. OH is a 1 minus ion. Plus, no, hang on a minute. Words to symbols. I'm an idiot. Sorry, folks. Iron 2 hydroxide. So I'm going to go to iron 2 sulfate. That one, you'd have to have it to get that mark. Iron 2 sulfate plus water. You're done. Right. Equation. So iron 2 hydroxide. Iron 2 hydroxide plus sulfuric acid is going to go to FeSO4, iron 2 sulfate, plus water. Balance the equation. I think you'll find 2 waters. Yeah, there you go. 1 iron, 1 iron. 2 oxygens, 2 oxygens. I'm not counting the sulfates because I keep the sulfates together. Remember, it comes with practice, folks. It comes with practice. The more you practice, the better you get at this. I think that now adds up. Next. Okay, words. Nitric acid plus calcium oxide. Calcium, word to symbol, Mr. Duncan. Calcium nitrate. Don't need the Roman numeral because it's in group 2. Plus water. Very easy to do that. It's a bad habit, isn't it? Plus water. Let's balance. Let's now draw the symbol equation balanced. HNO3 plus calcium oxide forms calcium nitrate plus H2O. Can I just point out, by the way, Mel, I want you to know I am recognizing that this is a hard homework. I don't usually try and set you guys homeworks that take too long. I'm sorry this is too long. I apologize. 2 nitric acids, and I think I'm done. Yeah, I'm done. Next. Sulfuric acid plus ammonia. Clever, only salt. Ammonium sulfate. Ammonium sulfate. Right, equation. Sulfuric acid, H2SO4 plus ammonia, NH3, goes to NH4, close brackets, 2 SO4. Going to need 2 ammonias and done. There we go. So what I'm going to do is I'm going to give you guys, obviously, a mark for the word and then also a mark for the balanced symbol. Yeah, seems reasonable. And then, obviously, for this one, it asked you for name. So just check that you got the copper too. Otherwise, I think most people will get those right. Yeah, I do realize that this is a long homework. I'm sorry. And there's going to be 1 mark for each of those. That's another 50. I'm sorry that it's a long homework. Mel, if you ever, honestly, if you don't have time, always just leave it wherever you get up to. Don't worry about it. I'll never, ever be mad at someone for not doing a homework. I mean, if you don't, I'll get annoyed if you do it repeatedly. But, in general, I know you guys are so good. You guys are great. Right, they've reversed it. Zinc sulfate, water, CO2. So we'll have started with zinc 2 carbonate. Don't actually need the 2. Wait, we had to write the symbol equation. We didn't need to write the symbol equation for number 1. Oh, yeah, 2 to 9. It says 2 to 9. You're absolutely right. Ignore that one then. There you go. Zinc carbonate plus sulfuric acid. Words. And it is from 1 to 9. So zinc carbonate. Students wondering how I managed to get the carbonate. The carbonate came from the carbon dioxide. Zinc carbonate plus sulfuric acid. Sulfuric acid gives me zinc sulfate water. Let's write the equation. I'll do this one, I guess, underneath. ZnCO3 plus H2SO4 goes to ZnSO4 plus H2O and CO2. Balance the equation. I think you'll find it's already balanced. Oh, I didn't realize. Don't worry about it. Not a big deal. Libby, don't worry about it. It's going to make it awkward to mark. Next. Right, words again, magnesium nitrate. Oh, so that's interesting. Hydrogen, we put in a metal. Yeah, so this is now going to be magnesium. Magnesium plus nitric acid. nitric acid, goes to magnesium nitrate and hydrogen. That seems reasonable. Do the equation. Mg plus HNO3 goes to MgMO3 twice plus H2. Balance it with a 2 there. I'm going to just do them now. Yep, it's fine. Do it now. No problem. Ammonium nitrate. Ammonia plus nitric acid goes to ammonium nitrate. Equation, NH3 plus nitric acid, HNO3, goes to NH4NO3, ammonium nitrate. Otherwise known as fertilizer. That's actual fertilizer. That's what they put on plants. Next. Ooh, this one's interesting. Potassium. Oh, that's clever. Acid is hydrochloric. Hydrochloric acid plus potassium oxide goes potassium chloride and water. Equation, HCl plus K2O goes to KCl and H2O. Equation needs balancing. 1H, 2 H's, 2 H's, 2 H's, 2 Cl's, 2 Cl's, 2 K, 2 K's and 2 K's is already done. There we go. The K2 is already there. Finished. Next. Last one, and we're done. Calcium hydroxide going to calcium citrate. Ooh, citric acid. I've never taught it to you. Citric acid goes to calcium citrate plus water. Oh my goodness, equation 1 to 9. Oh, there you go. Wowza. Citric acid. Number 1, it's organic because we eat it. Yeah, it's in fruit. We know that, which means immediately it's weak. See what it looks like. There you go. There's citric acid. Ha! What a nightmare. Do you want to name it? A2 naming this. No, it's actually first year degree. It's outside A levels. This just passed it. Yeah, because you can't. You don't learn about carboxylic acid groups being in the middle of a chain. You don't learn about that. 3 carboxy, 3 hydroxy, pentane with the E, dioic acid. Nasty. So it's got 3 acid groups. Just show you the acid group. There's the we recognize this from doing a bit of organic acids already. That's the carboxylic acid group. That's what makes the acid an acid. I could convert that into an equation if you wished. Don't really want to, though. Nah. I'll have to go into molecular and just be a bit of a faff. Anyway. Right. So, final marks. Words, symbol, words, symbol, words, symbol, words, symbol, words. It's a long homework, this. I do apologize. Didn't mean it to be quite so long. Why does it have 3H though? Why does it lose 3H though? Oh, because each one of them's a carboxylic acid group helping. Remember that the carboxylic acid group, yeah, COOH, which is that structure there, yeah, this structure, yeah, what happens is this bond here breaks and the H plus can leave, yeah. And there are 3 groups of it. Yeah, so it would become the salt citrate, The citrate will be this. Yeah, all of those acid groups lose their H pluses. The hydroxy group doesn't. That's just an alcohol group. Doesn't really do anything. Yeah, but each one of them does. I can give you the equation if you really want me to. I'd have to convert it to molecular. C6H 1, 2, 3, 4, 5, 6, 7, 8. O a lot. Didn't do myself any favors with that, did I? Drawing O's everywhere. O's 7 plus calcium. What was it? What was calcium? Calcium hydroxide. Right, so the calcium hydroxide is the base. Idiot. There you go, to 2. So what I don't see, this is the problem with molecular. When you get to this kind of complexity, it becomes messy. It's a bit of a nightmare, really. What I would want to do is I'd want to separate out the acid groups. It just becomes a bit of a nightmare. What I would do is I'd do C3H5 O COOH, and then I'd put that in brackets 3. So I knew that there were 3 acid groups on it, and each one of those is going to give up a H plus. So you're going to need calcium's a 2 plus. Calcium's a 2 plus the citrate ion, C3H5O bracket COO 3 minus. Yeah, that would be a 3 minus ion. Cross them down. Going to need 2 of them. To form, cross them down, I need calciums with 3 brackets C3H5O brackets COO 3, like that, times 2. Nightmare plus water, balance it. Meh. Something. Well, I need to balance the calciums first, and then I need 2 of those anyway. So it's going to give me 3 waters, isn't it? Yeah. Is that right? No, it's not. It's going to give me more than that. It's going to give me more. It's going to be 6. There you go. No, I don't know. Anyway, I'm not trying to. It's just nice for me to show you how this expands. Never 6. Yeah. Thanks, Alpine. Yeah. I'm just quite nice to show you these evolutions and how things change. You realize in reality, I mean, apart from the translation out of horrible pictures and into what is, by the way, that's a disgusting formula. That is a mixture between structural and molecular. It's disgusting. Shouldn't do that, really. It's horrible. I could do the real one for you if you like. Oh, it's just getting so messy. It's all a language. You get used to doing these games. Anyway, let's go back to my lesson. I've only got 25 minutes left. Right, guys, this is going to be interesting. Solubility key stage 3. Right, guys. So how many marks was it out of? How many marks was it? A lot. 5, 15, and many. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's out of 18. It was a massive homework. I'm so sorry. It's out of 38. Holy moly. Yeah, out of 38. It's massive. I feel really, really guilty now, Mel. I'm sorry about that. Okay. Right, I think what I'm going to do, it was a long homework that, and I know that you guys have got to put in data and make corrections and whatnot, so I'm going to end my lesson early. I do feel very guilty. I didn't really expect it to be quite so long, and I'm sorry. So if we didn't put the Roman numeral for part B, question 1, is it wrong? No, Laura, you can have it. They didn't even put it in the first place. It's absolutely fine. You can have it. I'm going to end my lesson early. So you guys have got one job, one task, which is to fill in the data sheet. Yeah, I'll bring that up now, just so I know what's going on. Try and track it down. Oh, Dominic. Don't, honestly. It was a long homework, and I do feel really guilty about it. And I'd like you just to take a bit of time, have a look at those equations, rewind the webinar, go through those with a bit more detail if you need some support with it. Give me a message if you get stuck. Don't be sad, guys. I'm giving you like an extra 20 minutes off the lesson. Come on. You do have a little bit of, like, you've just got to put in your data. That's all I need you to do. I know that you guys are probably already nearly finished doing that because you guys have just been amazing. Wow. This sheet has changed a lot since I've last looked at it. Who's put Avogadro's number in the middle? That's amazing. The formatting is just brilliant. I've got pictures of moles everywhere. This is amazing. Love it. Acid base 38, 36 moles. Who did that? Was that Libby? Love it. No, it was Lynn. Love it. Well done. 36. Smashed it. Well done, Libby. Tiny pictures appearing. Guys, yeah, like, I feel really, really guilty about the homework being as long as it was and not giving you enough time. And I'm really sorry about that. It was never my intention. But chem lessons are good lessons. Oh, saddest moment of my life right now. Dom, that's a bit of an over-exaggeration. A gram... Oh, somebody put something about uranium and I just missed it. Looking at calories and uranium. That's an interesting thing. Guys, you don't need to love all the pictures of moles in, like, I am the mole god. It's amazing. I'm going so that's a fast mole. He's looking very blurry. That is really funny. They're great. Guys, what I'll do, so you've got no homework tonight. None. I would have usually given you a solubility homework, but I'm not going to give you one. Go and have a nice rest of your evening. I'll give you the lesson on solubility tomorrow. So all you've got to do is get that data in, and I can see that the data is already trickling in, which is amazing. Thank you so much. And they're great results too. Thank you. Really appreciate it. You're doing brilliant. Guys, have a nice rest of your day. Have a nice rest of your evening. Enjoy the extra 20 minutes. Get your data in and you're done. Guys, I'll see you all tomorrow for solubility. You're more than welcome. See you later, guys.